All right, this is it, the finale of our Sentinel series from TradingMaster AI. We've talked all about the brains of AI, the agents, the grounding, the data pipelines. But today we're talking about the brawn, the raw physical power that makes it all run. We're going to optimize the power grid for AI. Let's get into it.
So let's start with what is, without a doubt, the single most expensive problem in all of AI infrastructure: idle time. I mean, look at this quote. If your storage lags, your $1,000,000 GPU cluster sits idle. You can have the most incredible accelerators on the planet, but if they're just sitting there waiting for data, you're not just wasting time, you are literally burning cash. Every single nanosecond of latency costs you. And seriously, this isn't some kind of metaphor. When you're pushing petabytes of data into thousands of compute nodes, your elegant code isn't going to save you. It becomes a brute force battle against the laws of physics. You need absolutely massive throughput and ultra-low latency. If you don't have it, the whole system just grinds to a halt. Okay, so that brings us to a really critical point: choosing the right engine for this fight. Because the heart of any AI machine is its accelerator. And let me tell you, this one choice defines everything else about your system. This is really the first big question you have to answer, right? Do you need the incredible do-anything versatility of a GPU, which can handle everything from training custom models to rendering amazing graphics? Or do you need a hyper-specialized, brutally efficient scalpel like a TPU, which is designed for one thing and one thing only: massive-scale machine learning? It's a huge decision. And this table here, it just frames that core trade-off perfectly. You've got GPUs, like the NVIDIA H100, which are famous for their parallel processing power. They're perfect for building all sorts of custom deep learning models. But then you have TPUs, and they are the undisputed champions of large matrix operations. You know, the math that underpins every large language model. Oh, and here's the kicker. They give you best-in-class computations per watt, which makes them way more energy efficient when you're working at a massive scale. Now, let's say you do lean towards the flexibility of GPUs. Well, your job isn't done yet. You've got to think about these 4 factors. How much memory is your model going to eat up? Are you training from scratch, or are you serving inferences? How big are your training batches going to be? And what kind of data are you working with, like high-res images that need tons of memory? Your answers to these questions are going to point you to the exact right GPU setup. But what if you didn't have to choose just one? You know, there's a really powerful hybrid strategy out there. You use TPUs for what they do best, that incredibly efficient, large-scale training. And then you take that trained model and deploy it onto GPUs to take advantage of their flexibility and, frankly, wider availability for serving it out to your users. It's a best of both worlds approach that can slash your costs and seriously speed up your development. Okay, but here's the thing. Even the world's most powerful accelerator, whether it's a GPU or a TPU, is completely useless if it's starved for data. And that brings us to the data pipeline. Because feeding the beast, well, that's where the real physical battle is won or lost. To really get high-performance storage, you first have to understand this concept: a parallel file system, or PFS. So think about it like this. Traditional storage is like a single-lane road. Everything gets bottlenecked. A PFS is like a 100-lane superhighway. It spreads the data across tons of servers, so thousands of your compute nodes can all grab data at the exact same time. The result is just absolutely massive throughput. So this table really lays out your 2 main choices for feeding those hungry accelerators. On one side, you've got Managed Lustre, a true parallel file system. It's a speed demon with small files and gives you that ultra-low latency. It's perfect for the insane demands of model training. On the other side, you've got Cloud Storage Fuse. This lets you tap into the massive scale of cloud object storage. It handles huge files like a champ and is built for durable multi-regional serving. Let's just focus on this number for a second: sub-millisecond latency. When you're training a huge model, you're constantly saving your progress. It's a process called checkpointing. And these frequent, small write operations can absolutely destroy a slower storage system. For this kind of intense workload, the sub-millisecond latency you get from a PFS, like Managed Lustre, it isn't just a nice to have. It's pretty much the only thing that works. Now look at this number: 1 terabyte per second. When you shift gears from training a model to serving it to millions of people all over the world, your priority changes. It's less about latency and more about massive, scalable throughput. And cloud storage can scale up to an incredible 1 terabyte per second. That's the kind of muscle you need to serve enormous models and data sets cost-effectively across the entire globe. All right, We've looked at the accelerators, we've looked at the storage systems, so now let's put it all together into a clear, actionable blueprint that matches the right hardware to the right mission. The whole AI lifecycle really can be broken down into these 4 distinct stages. The key thing to get here is that each stage has a completely different performance profile. It needs a different tool for the job. You prepare your data, you train your model, you serve it to the world, and then you archive everything for later. And this is the whole thing, the big takeaway. You architect your storage to match the stage of the mission. For the initial data preparation, you use the massive scale of cloud storage. For the intense, low-latency demands of training, you switch to that speed demon Managed Lustre. Then for serving, you go back to Cloud Storage Fuse, maybe with a cache for high availability. And for long-term archiving, cloud storage is again the most cost-effective solution. This, right here, is the final blueprint for an optimized AI power grid. And with that, our Sentinel series is complete. You now understand the full stack, from the foundational hardware we covered today, all the way up to those autonomous agents we started with. You have the blueprints to build powerful, efficient, and truly intelligent systems for the AI era. Thank you for joining us. We've given you the blueprints for the power grid. Here at TradingMaster AI, our motto is simple: build fast, build secure, stay architected. And now that you have this power in your hands, there's really only one question left. What will you build?